Hey guys, and welcome back to a new video and a new episode of Android Basics. In this video, you will learn about WorkManager. In the last video, you learned about foreground services, which are used to just have something running in the background, which the user is actively aware of, such as when you track a run of the user or when you have some music playback, so just some kind of service or functionality that is active all the time in the background. And WorkManager, on the other hand, compares to that at least. Because with WorkManager, Google offers us something that helps us to execute tasks and functionality reliably. And these are tasks the user does not directly need to be aware of. You can show a notification when the task is running, but you don't have to in comparison to a foreground service. So this could be things like if your app needs to synchronize data in the background. So that could be something that runs periodically. So for example, every 30 minutes, or just a one-time task. And sometimes your app just needs to do these longer running things. For example, imagine your app needs to upload 20 images to a server. Then that can obviously take a little moment, especially if your user does not have a strong internet connection. And what would now happen is if you put the code to upload these 20 images directly in your app, if the user then closes the app because they might not be patient enough, the upload will be cancelled. And that is where WorkManager comes into play, because it guarantees that your task will be executed. And I could just show you the basics here of WorkManager, but I don't think you will learn it really well with that. So I want to also have a real live use case, which I will show you here. That will include some new things like interacting with the file system, which I will of course explain, but I think that way it gets the clearest. In particular, what we will build here is, right now it's just a blank app, but it actually does something. If we go back to Google Chrome, then this behavior I will now show you is something you already know if you watched the previous Android Basic videos. So especially if you watch the video about intents and intent filters, because that is something I won't cover here in this video. I will assume you know this. If you don't, then please watch the video about intent filters first. But what we want to do here is we will be able to long click on an image in our Google Chrome browser, which is a little bit late here. And then we click share image. We want to get that image in our app. We select the WorkManager app here, and then you can see we have an uncompressed photo and a compressed photo. You can see the quality is quite off here because it's compressed. It's just a much smaller size. And you also notice that took a little moment, a few milliseconds in this example, but this compression is effectively handled in such a worker of WorkManager. And why is just compressing an image a potentially long-running task? Because in this example I will show you here, we want to give a specific file size we want to compress this image to. And it's not really predictable when choosing a quality for that image we want to compress it to, how large the image will be after compressing. So we can't really predict by how much we need to compress it if we want it to be, let's say, 1 megabyte large. So instead what we do is we compress it just a little bit, check the file size. If it's still too large, we compress it a little bit again, check the file size, and so on. So we could need to compress it quite a lot of times to fit in, or to finally find this right quality. And if you not only do that with one image, but potentially multiple ones, which you need to upload to a server, for example, then this can actually take a little moment. And we will actually do that in a worker. That is how we call the things that WorkManager controls and runs. And jumping into an empty Android Studio project, the only thing you need to do to be able to follow from the beginning here is to add these two dependencies in your build.gradle module app file. So in this dependencies block, since WorkManager requires to have this work runtime dependency, and we also want to have the call compose dependency, which I've used in an earlier video of this Android Basics playlist, which is just used to easily show images. Make sure to synchronize the project, and then we are good to get started. The first thing is we want to be able to send the image from Chrome or from any other app that can share an image to our app. And for that, we go to our manifest. That is something I taught in the video about intent filters. And here below this intent filter, we just declare another one. The action would in this case be send, since we want to send an image to our app. Then the category would be default. And then last but not least, we have our data, specify the MIME type, which is just image/asterisk. So we're just looking for any type of image. And now I would say we just get started implementing our worker. And that is also nothing else than just a normal Kotlin class. So here in our root package, let's create a new Kotlin class called photo compression worker, for example. Select class. And now there are different types of workers, but we are interested in a so-called coroutine worker. So this is just a worker that is running in a suspend function, so it's asynchronous in the end. And you can also see we get a bunch of errors because we need to add some default constructor arguments here. On the one hand, that is the application context. And on the other hand, that is a set of parameters of type worker parameters. So if we want to attach some data to this worker, so just pass some kind of parameters to it, we need to do this with these worker parameters, and we can then retrieve it with this variable here. Because we won't instantiate this class on our own, that is what the Android system will do, and that is why it also needs this extra parameter here, since we can't just pass as many values here on our own as we want. There are ways to also inject or to also pass more variables here to the constructor, but I won't get into that in this video. We now need to take these two variables, pass them here to the constructor of coroutine worker. Then this error is gone, but we add another one because we need to override the so-called doWork function. And that is where the magic happens. This is the function that will be executed when we want to run our worker. So we could potentially just run it once when we, for example, want to upload a set of photos. But if we, for example, want to synchronize our data frequently, maybe every 30 minutes, as I said, then we can also run this periodically. So then this doWork function would be executed every 30 minutes reliably. And we can then also later specify so-called constraints, so just conditions under which this worker will run. So such a condition could be the Android device needs to be connected to the internet. If you're dealing with a data synchronization, that obviously needs to be the case, and Android or WorkManager will then already take care of that this doWork function will only run if your device is connected to the internet. And if we take a look, it returns a result. So we now need to tell this worker in which scenario this work is considered a success, in which it's considered a failure, and in which scenario we want to retry the work at a later point. And let's actually get started implementing this function. So what do we want to now send to this worker? Well, we want to send an image to it, but it's not so easy to actually send a whole image in form of bytes to this worker because there's a limit in byte count that we can send to this, which is I think 10 kilobytes. So it's not enough for an image. So we instead want to send the URI, so the actual address of that image, which we can then use to retrieve the actual bytes of that image inside of this worker. So val string URI is equal to our parameters dot input data, that is the set of data which we can pass from the outside. And here we want to get the string. Now we need to specify a key, so under which key or how we identify this specific piece of data, this URI. And for that, I would like to have a companion object where we have a const val key content URI, and that is just a string key content URI. We also want to specify two more of such keys, since we have two more pieces of data we need to take care of here. On the one hand, that is the key compression threshold, which will specify the final file size in bytes up to which we want to compress this. So if this is, for example, 10 kilobytes, then we will compress the image until it reaches a maximum size of 10 kilobytes. And for this third key, we actually want to have a key result path, which will be the file path of the final compressed photo, which we'll then pass back so we can then read it in our activity and show it in our composable. So here for the string URI, we then want to pass our key content URI, and we also want to have our compression threshold in bytes. This would be just a long value, so params input data get long, and here we pass our key compression threshold, and the default value is just 0L. We then want to take our string URI and actually make a real URI of that. So that is an extra data type of Android, but we can't pass that here in such an input data map. So we need to say we have our URI, and that is equal to URI from AndroidNet.parse. And here we can then pass our string URI to construct the real URI out of that. And now having this real URI, we want to take that and read the actual bytes of the image here into memory. So we say val bytes is equal to our app context, that content resolver. So the content resolver is used to, resolve some content, such as such an image from our URI. And maybe I will actually make a separate video about URIs itself, because you need these quite often in Android and the different types of URIs. But if you have a so-called content URI, which this URI would be if we share it from another app, then we need the content resolver to read that URI in as a byte array. And specifically, we want to open an input stream here. So a stream that will read this URI, we pass it here, and then we say !use, and we now get an input stream we can then use to actually read the bytes. That is super simple. We just want to say it.read bytes that returns a byte array, which will be saved in this bytes variable. Use, what that will do is basically it will just make sure that this input stream is automatically closed after we use it, so we don't need to take care of that on our own. But what now happens if this URI doesn't exist? So if we pass some kind of invalid URI, then this would return null, and we wouldn't have a byte array here, because if you take a look, it's a nullable byte array, and with a nullable byte array, we can't work. So if it's null, we want to return here, and now we need to return such a result. We can construct that very easily by just saying result dot, and we have failure, retry, or success. Since in this case, if the URI is invalid, it obviously failed, we want to return result.failure. And we might also want to consider switching the coroutine context here to the IO dispatcher, since we're dealing with IO operations such as reading an input stream. So what we want to do is want to return with context. Now, if that is new to you, then please watch my separate coroutines playlist. That will be too much to explain that in detail here, what this with context block does. But it pretty much just makes sure that this code runs on the on an optimized thread for IO operations. So right here, we return with context. Then we also need to modify this return to return at with context. And then down here, we can go on. Because right now, take a look again, this is now a not nullable byte array anymore. So now that we have our byte array, how do we actually interpret that as an image and compress that image? For that, we need to convert it to a so-called bitmap. That is just an image object that we use in Android, so val bitmap. And we can also easily construct that with a byte array by just saying bitmap factory, decode byte array. Here we need to pass that byte array we want to decode, which is our bytes. The offset is 0 because we just want to start from the very beginning of that byte array. And the length is simply bytes.size. And now bitmaps also offer this bitmap.compress function, which allow us to specify this quality here. So if that quality is 100, then that means it's 100% quality, so the highest quality, pretty much lossless quality. If we set this to 50%, then it will be compressed by 50% and so on. But again, as I said, this is not predictable in which file size it will result after compressing. So you can't just say if the quality was 100 and it's now 50, that the file size will also just be divided by 2. It's sadly not that simple. So instead, we just need to compress it a lot of times until we finally hit the right file size. And for that, I want to have an output stream this time, since we now want to take the compressed bytes and write these out in this stream. That is simply a byte array output stream. Or we can also just specify the type here, by the way, like this, because we will initialize it right after. And we want to have a quality variable here, which starts at 100%. Because if the image already fits in our desired file size, then we don't need to compress it. So we just start at 100% lossless quality. And then we will use a do while loop. So we first want to do something before we check the while condition. And in here, we actually want to define our output. Oh, actually, I wanted to define the output bytes up here, not the stream itself. So these need to be bytes and a byte array. And in here, we will have the stream. And that is now a byte array output stream. Because with every iteration of this while loop we will create here, we will create a new output stream, read in the new compressed bytes, and then check how large that array is, which would be the byte size. So we can then take this output stream, call that use again. Here we get that output stream, and we say bitmap.compress. The format would be bitmap compress bitmap format, or actually compress format .jpeg. The quality is just what we have for quality, and our stream, we want to compress that into is our output stream. Then after that compression is done, we say our output bytes is now equal to our output stream, that 2-byte array. So that is now the compressed bytes after this compression happened. So the little bit smaller image, you can say. And then we say our quality minus equals quality times 0.1. So we just subtract 10% of the current quality, and we say round to int. And then we check again with that new quality if after that compression it finally fits in our file size. If not, we will compress it again with a little bit decreased quality, again 10% less, and we try again. So after this do block, we now have a while loop, where we will check if our output bytes.size, so that is the actual byte count of that compressed photo, as long as that is larger than our compression threshold in bytes. And let's also have a check that the quality is larger than 5, because then it doesn't make sense to further compress this. At some point, we just need to stop. If that condition is given, then we just repeat this do block. So then we again define a new array output stream here. We again compress it with the new quality, which was decreased in the last iteration. And then we again check, okay, is it now a good size? If not, we just do this whole thing again, and so on. And now, since we want to return a file path, so key result path here, we need to just put that in a file and save it in our file system in our Android storage. Again, for details about Android storage, I have a whole playlist that is quite complex, but in this specific use case here, it's actually very simple. So we just want to say val file is a new file from Java.io. Here we need to give it a parent and a child. So the parent would just be the path where we save it. The child would be the actual file name. We can get the directory with app context.cache directory. So we just want to have a cached files. We don't want to persistently save it in our file system, at least forever. And we now need a unique file name. We could also choose a hard-coded file name here, since we only save one file at a time. But if you want to potentially save multiple images at the same time, you of course need different file names. You could use the ID of this worker, because every single work request or worker has a unique ID, which you could use here from params.id. And we could say that JPEG, for example. Then we go down here, we say file.write bytes. So we just take our output bytes and write these into our file. So here we now have that file finally saved on our file system. So we now can return a successful result here, since we're now done. So just return, actually we can just say result.success. And here we can either just return success, or we can also provide an output data. So if we have some data to pass from this worker to whoever calls this worker, then we can pass that data here in this with this output data parameter. And we actually do have output data, because we want to pass the file path from this file to our activity later on. So we say work data off. That is how we construct that. And here we can just put in lots of pairs. On the one hand, the key on the left side, so key result path, and then we say to, and then followed by the actual path in this case, so file.absolute path. And yes, that is an example of a WorkManager worker. And in here, you can do pretty much everything you want, which is a long-running action, and the Android system will then guarantee that it is called. You also have the option to call something with Foreground, set Foreground. So if you also want to show a notification while this worker is running, you can also do that. So that would then really compare to a Foreground service, just that this is kind of expected to finish at some point. While Foreground service is rather something that could be active all the time, and that does not have a specific finish time, or rather it is up to the user when the Foreground service finishes. So when the user stops listening to music, when the user finishes their run, so the notification will hide or actually be completely removed and not shown anymore. But on the other hand, if you execute things in a worker, then that is just something the app needs to do, which isn't connected directly to a user action. So I hope that somehow got clearer, but let's now take a look at how we can use this compression worker and execute this work request. And for that, we want to go back to our activity. And as I showed in the video about intents and intent filters, we want to override on new intent here. And this function only makes sense to be override if we go to our manifest and declare this activity as single top. So launch mode single top. Since then, the onNewIntent function will be triggered. And in here, we then get the intent, which contains the URI of the photo we want to compress. So that will be the photo that comes potentially from Google Chrome. So let's first of all retrieve that URI with the method I showed you before. So I'll first check on which version this Android device is running, build that version SDK int. If that's larger or equal than, build that version codes that tiramisu. Then we want to say intent that get personable extra, and we say intent that extra stream. Here we also want to specify we actually want to have a URI. Alt enter to import that URI :class.java. And if we're running on a lower version, we also say intent get personable extra. But here we just say intent extra stream without specifying the class. If there is no URI, So if that's null, we can just return here. And now what we need to do to launch this worker is we need to define a work request. With that, we can define some configuration, so basically conditions that need to be true to execute this work request. We can pass our initial data. We can set a time when it should run. We can set a delay. So these kinds of things. So we want to have a request here, and that can either be a one-time work request or a periodic work request. So periodic, as the name says, would run frequently, so every X minutes, every X hours, every X days. If you, for example, want to synchronize your data every hour, then this is the work request to pick. However, if you just want to execute this once, or every time the user does something like upload some photos, then you want to have a one-time work request. So when I say one-time work request builder, here we need to define the type of worker we want to launch, which is a photo compression worker. And then we can now configure that. On the one hand, we want to set input data. So set input data, that is now the same thing we did as the output data. So we have a work data off, and here we specify the pairs which we retrieve in our worker with these functions here. So get string and get long. So we need to provide the key content URI on the one hand and the key compression threshold. So back here, we'll have our photo compression worker key content URI. And that is our URI that we have read from the intent. So URI.toString. And we also have our key compression threshold, which is something we can specify here. So for example, 1 kilobyte times 20, that would mean we want to compress the image that we pass to 20 kilobytes. Then something else we can do is we could set constraints, as I mentioned. So here we can initialize constraints. And then decide, okay, does our worker require internet? So then WorkManager will take care of that and not execute it if there is no internet. Since we're just saving files, that is not required. Requires charging is something we could set so that the device is connected to a charger, that it's idle so that the user is not doing something, that the battery is not low, that the storage is not low. That is something we might want to consider here since we're saving files. So all those are just edge cases that can always happen, but WorkManager makes it very easy since it handles this for you. And there are just a lot more things we could define here. So we can also define if we have multiple workers, we can chain these, that the first worker gets executed, then the second one passes some data to the next one. So there's really complex stuff we can do with WorkManager, but usually you're just dealing with this more simple stuff. But you could also, for example, define a bag of criteria. So how should WorkManager handle when you want to retry the result? Should it be a linear policy so that it retries, for example, every minute? Or should it be an exponential policy that the time until the next retry just grows exponentially? So there are a lot of things you can configure here. You can set an initial delay so that it waits, for example, 10 minutes until it executes the work request. You can schedule it. So lots of cool things to play around with. We just want to call build here to finally build our work request, which we haven't fired off yet. To fire it off, we need to get a reference to WorkManager itself, which you can just have a public variable for, actually a global variable, not a public one, a private var or latent var. WorkManager is of type WorkManager. We then initialize this here is equal to WorkManager.getInstance, and we pass our application context. Then going down here, we then say WorkManager.enqueue. So we have enqueue here, we have enqueue unique work and enqueue unique periodic work. So enqueue would just enqueue this single work request which we have here, which is the one we want to choose. Enqueue unique work would make sure that there's only one instance of your work running. So there could only be one compression at a time, which doesn't make sense in this case. And now with enqueue, WorkManager will just take care of executing that work request at the best possible time. So if the storage is maybe very low for the user, then WorkManager won't execute that right away, but rather wait until the user has some storage again. But how do we now get this result of the worker, which we pass here, this absolute file path, inside of our activity and really display that in an image? For that, we just need a little help of a ViewModel, which we want to create here to just have some states which we can update there. So photo ViewModel, for example, make that inherit from ViewModel. Here we want to, on the one hand, have an uncompressed URI, which is a nullable URI. Alt enter to import that by mutable state of null initially. So that's just the URI of the uncompressed photo. We can alt enter to import that, make it a private set, and then also have a var for our compressed bitmap. Now, nullable bitmap by mutable state of null initially. So there's the compressed photo, which we can update here to trigger a change in our UI. And finally, we want to have a var work ID, which is a UUID nullable by mutable state of null. Since when this work ID changes, we need to also change which worker's data or which worker's result we observe and where we listen for changes in our UI. So also have a private set here, and actually here as well. And then just provide some functions to update these values. Function update uncompressed URI with a nullable URI. When we say uncompressed URI is URI. We then do the same for the other fields. Function update compressed bitmap with a nullable bitmap. Compressed bitmap is bitmap. And last but not least, update work ID with a UUID. And we say work ID is UUID. Oops, like this. We can then go back to our activity and instantiate such a view model. Up here, private val view model by view models. This one here, specify the type of view model, which is photo view model. And then we can now update the values of our view model here in our onNewIntent function. That will then trigger a change in these states. And that, however, will then trigger a change in our UI block here. That is just how we communicate from this onNewIntent function with our actual compose code. So here in onNewIntent, after we retrieve the URI, we can call ViewModel update uncompressed URI, which is just the URI we get from the other app, from Google Chrome, for example. Just pass URI here. And after we've enqueued the request, or actually created the request, we can say ViewModel.update work ID with request.id. So that will then allow us to listen for updates of that specific worker we've launched here with this request. So if we now scroll up to our actual UI, we can listen to the worker result here by saying is equal to ViewModel.workID. If that is not null, we get the ID here, and then we say WorkManager dot get work info by ID, actually by ID live data. Live data is something I haven't covered here, and I also won't cover in this Android Basics playlist, but it's basically an observable data type. So something that triggers whenever there is a certain change. In this case, whenever there is a change in this work info. So for example, if the result is ready, and that is just lifecycle aware. So it makes sure that there are no leaks inside of an activity. So here we can then pass our ID, which we got from this work request before. And we can then convert that to compose state by saying observe. And I'm noticing there's actually a dependency missing to have this function which converts this live data object to a compose state. So we actually always get the update in compose whenever the worker is finished. So let's just go to our build.gradle app file, scroll down, and also paste this dependency. You can also find this in GitHub below, but also just write it off. Probably very quick. Synchronize now, go back here, and then have observe as state. This green function here is the one we want. Press enter, and now we have a worker result, which is the state of work info. You can also directly refer to its value, so we just have the work info we're looking for. And that, however, again, now also contains the result of our worker, which we can then react to in our compose code. So now what we can do is we can have a launch defect block with our worker result dot output data. So whenever our output data changes, this piece of code is executed. And we now want to check if worker result dot output data is not equal to null. So if there is some output data, we want to do something. And specifically, we want to retrieve the file path of the file of the compressed URI, of the compressed photo. And we get that with worker result dot output data. We don't need the null check here, but here, actually not get string, and the key is photo compression worker key result path. So here we now retrieve the file path that we passed to this successful result here after our worker was running. And if that file path now exists, we know that the compression is definitely finished. So if it's not null, we can reconstruct the bitmap out of that file path. So we can read that file as a bitmap by saying bitmap factory decode file, and we just pass our file path here. We then say ViewModel update compressed bitmap, and we pass this bitmap. That will then trigger a change of our compressed bitmap state, which we can then again listen to in our compose code, which will come now to just display these two images. Let's have a column, modifier fill max size. We want to center that, center vertically and horizontally. And in here, if our ViewModel that uncompressed URI, if that exists, so if we shared a URI, then we want to have a text for the uncompressed photo, followed by the actual image. So we use async image from coil, and here we display the content URI. We don't use a content description here, and we can then also have a little bit of spacing here. So a spacer with height of 16 dp, for example. Alt-Enter to import dp. Copy this piece of code, paste it here. This time I want to listen to the compressed bitmap. So this time we get a bitmap. For that, to display that, we don't even need coil, so we can just display a normal image here that takes in this bitmap. And the bitmap is just it, that as image bitmap, which is just a compose version of bitmaps. We pass null for the content description, and that should be it. I would say we launch this and try this out. This is obviously still the old app, but let's take a look if we can compress a photo from Google Chrome now. So right now, nothing is displaying. If we switch back to Google Chrome, actually that is not Google Chrome. Let's close this and scroll down, maybe take this photo here, a long click on that, click share image, and want to click on more. And then we want to select our WorkManager app that appears here. Click that, and nothing is working. Okay. Well, then I need to take a look at what that is, and then you will hear back from me. Okay, it seems my code was working well, but that this constraint was actually meant that my storage was low on this emulator. So maybe it just worked for you right away. I'm not sure what the exact byte size is that WorkManager will look for. So if the device has less storage than the specific size, that it won't execute the worker. But I removed this constraint here, so don't have it anymore. And now, as you can see, it's working fine. If we go back to Chrome, I'll take this image, for example. Can I long click on that? No. Go back. Yes, share image, share with WorkManager. And then you can see it will update the image in the app. And again, let's try it one more time with this happy birthday. Share image, WorkManager. There we go. So now it's working every single time. Obviously, the constraints are working, as you can see, but that is, of course, something you need to decide for your individual use case. If such a constraint is really necessary for this use case, I don't know. You would need to look into the exact file size that shouldn't fit anymore on the device's storage. But even without this constraint, you can see we can save a lot more images here on our device. Compression also seems to work. You can see it's a little bit blurry, and the pixels aren't as crisp as here. So that is looking quite nice. It's a little bit longer video of this Android Basics playlist, but I think WorkManager is important. I also have another comparable video about that. I also show these periodic work requests, but I think this video here, just fits more into this Android Basics playlist to really cover WorkManager from the beginning to end with a real world use case. So thanks for watching. If you enjoyed this, definitely leave a subscribe if you haven't already. Since then, you will get 2 more Android videos every single week about topics like these. And I wish you an amazing rest of your week. See you back in the next video. Bye bye.